Alrighty. Hello. Happy Thursday to my students, and welcome to week 6 section. Today, I have some reminders for you. We're going to chat about the midterm, and then we're going to go over prime implicant charts, and that really means Quine McClusky and Petrick's methods. So, before we jump into any content-wise reminders, homework 3 has been posted, and that is going to be due not January. We are past that month. February 23rd. You guys have a midterm next week, which is probably what is mostly on your mind since you just finished homework 2. Congratulations for turning that in. Think about this midterm. Yes, it's on Valentine's Day. If you don't like Valentine's Day, I'm sorry. If you do, yay. But fun fact, I did have a midterm once on Valentine's Day. God, I think my sophomore year. And we came out of the midterm so flustered and so panicked that I just went to like dinner with my friends that I took the midterm with, and we like chatted about everything that we got wrong. And I totally forgot that I had a date with my long-term boyfriend on Valentine's Day after that midterm. So if you're like me, don't do that. And if you don't have a date, treat yourself after the midterm, okay? And then last but not least, grade quiz 1. We are trying to grade that as fast as we can, but I can't release my quiz grades until all the other TAs have released the quiz grades because they're all kind of tied to the same assignment on Gradescope. So be patient. But if you do want access to the quiz answers, I'm thinking of putting them in my section notes, or you can always email me if you want our quiz answers so specifically. So midterm logistics. It is going to be Monday. February 14th during your guys' usual class time. It will be conducted over Zoom, so please don't show up in person. Don't make that mistake. Be from the comfort of your own home and have a nice, quiet spot. These 2 questions are, I think, the biggest ones. Are notes allowed and calculators? My answer is, I don't know. TBH, Professor Zhang hasn't mentioned what he wants specifically for the exam, but I'm assuming since it's conducted over Zoom, that he'll give you guys a little bit more leeway. So I would wait until Professor Zhang comes out with an email on that. If not, definitely that should be told to you guys over the chat, or at least the forum on Gaucho Space, the chat. No one's in anybody's DMs. So topics covered, textbook chapters 1 through 5. These are the chapters. I just copied the titles straight from the book. So numerical or number systems and conversions. So if you remember bases and radices, all that good stuff. That also includes binary arithmetic and like 1 and 2's complement in that chapter. Number 2 is a really big chapter for you guys, Boolean algebra. It's what you guys should be experts on by now. So hopefully that's true. Number 3 or chapter 3, it's more Boolean algebra, but it's just harder Boolean algebra. And so I encourage you to go look through these topics to find out more of what that means. And then 4 and 5, 4 being midterm and maxterm expansions. If you remember, that standard SOP and standard POS, sum of products and product of sums. And lastly, chapter 5 is K-maps, which is probably like one of the trickier, I think, chapters in this grouping. And so how that translates to your guys' lectures is I copied this straight from the syllabus, but you guys started out learning binary and just like numerical basics, and then you went straight into binary arithmetic. So if you remember, that's how to calculate a binary number. It's integer form and its fraction form. You have division and multiplication and basic addition and subtraction. And then lecture 3 is when you start getting into 1 and 2's complement, which is definitely, I think, a topic many people make mistakes on. Like I had a hard time learning this when I took this in undergrad. 4, Boolean theorems, identities, laws, all that good stuff. And then 5 is when you start getting into simplification and putting things into standard, or not standard, sum of product form and product of sum form. Lecture 6 is when professor starts talking about midterm and maxterm expansion. Lecture 7 is just more generalized midterm, maxterm expansion, but harder. And then lecture 8 is when he really goes into K-maps, and lecture 9 is talking about implicants and prime implicants and like harder, high-level K-maps and how to use K-maps to find implicants and prime implicants. So my best study tips: identify, out of everything I just mentioned, where are you most uncomfortable? What are your struggle topics? I think kind of narrowing down what you need to focus on studying. You guys have been studying for a while now, God, since high school. So you know how to identify, that's the easiest thing. What don't I know? If it's everything, study might be more intense for you. That's the name of the game. And then number 2, practice. This class, the exams, from what I remember when I took them, it's a lot. It comes down to crunch time. Like you come down to not having enough time to finish your work. And so you want to do a lot of practice doing a lot of the methods I mentioned above, especially when it comes to simplification, when it comes to using Carnot maps and Boolean algebra to do that stuff, and also doing binary arithmetic. Doing practice problems is going to get you in the groove of having it be like second nature. And so where do I practice? Both homework problems, that's a great place to start. And then also the textbook has a phenomenal set of study tools. And so I really recommend that you check that out if you want to study. And so, yeah, kind of about this class is you want to work efficiently. You want to minimize mistakes, but you also want to work fast because you only have, at least for the midterm, your class period time, which to cover a lot of these topics is going to feel pretty constrained on time. So read problems carefully. All right. It's really easy to mess up a complement and have it think, or you might think it applies to a certain term, but it applies to another term or like the outer expansion of the term. So translate your problems carefully, especially if you're writing it down on a piece of paper, because I know that's how some of us do it over Zoom. Check your work. What's cool about this class is that there's a lot of little tools and ways you can kind of sanity check your work along the way, especially when it comes to binary arithmetic and Boolean simplification. Like every step you do of Boolean simplification, you can kind of just like do a hot double take and say, does this make sense? And you'll be able to get in the hang of that if you do a lot of practice problems. And then lastly, what I would really recommend, memorize your powers of 2. This is how I am able to do a lot of these problems fast and able to double check my work. Because if you create a binary value, knowing your powers of 2 is going to speed that up a lot, and you won't have to do division method. So I recommend like memorizing your binary values up to like 2048. I played that game a lot when I was in high school, and hey, it helps me out in this class. And also memorizing your Boolean simplification identities. That's going to come kind of like second nature if you, again, do a lot of practice problems. So before I belabor the point of saying you guys should study for the midterm, I wish you the best of luck. And any questions you guys do have, start studying early and ask us over the forum or email your TAs. Because we're here to help. So on the agenda, wait, let's just look at what's on the agenda. Okay, prime implicant charts and Quine McClusky and Petrik's. So prime implicant charts. We remember K-maps, right? Sometimes K-maps aren't enough. Sometimes we have too many variables that we're working with, and finding the minimum sum of products or midterm expansion, just not midterm expansion with K-maps, but finding a minimal sum of products from a K-map can become really difficult if there's a lot of groupings going on. So prime implicant charts are a really useful tool for when you have too many variables. And actually they were kind of like, they're my favorite way of finding minimum sum of products. So let us get into it. We have a function, it's a four variable function. And so when you see 4-variable function, you can immediately think, okay, I can't have a midterm that's larger than 16, or sorry, that's larger than 15, because that is the most significant bit in a 4-variable function, right? But we have midterms 0, 1, 5, 6, 8, 9, and 11 and 13, plus the don't cares of 7, 10, and 12. Okay, so what we're going to do is we're going to list out binary values first. if you remember the prime implicant charts when you did this with Professor Zhang, there's 3 columns. So in the first column, you're just going to order all of these midterms and don't cares in or by how many ones they have in their binary value, okay? And so after that, we are then going to start grouping things. And after that, we're going to start grouping things in even more. So let's start with the first column here, where we have midterms 0, 1, 5, 6, 8, 9, 11, 13. So there's only one thing that has 0 ones. Sorry, I mean midterms 0, 1, 5. But that is the value 0. And since we only have 4 variables, you only need to translate this to 4 bits. So that'd be 0, 0, 0, 0. And then for only 1, 1, midterms with 1, 1 in them, just think powers of 2. And so in our midterms, I see that we have 8 and we have 1. All right, so those are going to be in this grouping, 1 and 8. And we all know that 1 is 0, 0, 0, 0, 0, 0, 0, 3 zeros, 1, and then 8 is 1, 0, 0, 0. Okay, so things that have 2 binary values in them, I usually like to think either it is 1 up from powers of 2, or sorry, not 2 binary values, 2 ones in them. I usually like to look for things that are above 1 plus a power of 2 or 2 plus a power of 2. So that is going to be for us 5, 6, 9, any of these values, and 12. 5, 6, 9, and 12. 5, 6, 9, and 12. It looks like I missed a guy. What did I miss? 10. I missed 10. And 10 is kind of like low-key one of those binary numbers that I like because in 4 bits, it's just 1, 0, 1, 0, or 10, 10. Anyways, let's start translating all of these numbers that I've gathered. So 5 is going to be 0, 1, 0, 1. 6 is going to be 0, 1, 1, 0. 9 is 1, 0, 0, 1. 10 is 1, 0, 1, 0. And then 12 is going to be 1, 1, 0, 0, or C in hex, if you guys remember that good stuff. And then we only have 3 midterms that have, when translated into the binary value, 3 ones in them. So those are going to be, if we look at our midterms and our don't cares, value 11, or let's go in order, 7, 11, and 13. So let's translate those things. 7, 11, and 13. And 7 is going to be 0, 1, 1, 1. 11 is going to be 10 plus 1. That's how I like to do it. And then 13 is going to be 12 plus 1. So we have translated all of our midterms and don't cares into the first column. Now, what happens in the second column? We are going to be finding pairs of binary values off by 1 bit. So we're going to start grouping things and we're going to start top to bottom on our first column of binary values. So I am going to, let's use another color. So we start with this midterm here, and we compare group 0. You can consider this like first group 0, group 1, group 2, etc. You look at group 0 and you say, okay, for these midterms, what bits below in the group below are similar and only off by 1? And so I'll give you an example. You can pair 0 with 1 and 8. So we can take the pairings 0, 1 and 0, 8. And the way that you would combine their bits is that, at least for 0 and 1, they both have the first 3 bits in common, which is just 0, 0, 0. And then finally, and either a 0 or a 1, depending on 0 or 1 for the value 0 or 1 for the least significant bit. And then same thing for 0 and 8, except it's the most significant bit, which is the thing that is different. And then they have, following that most significant bit, 3 identical zeros. Cool. So the way you do this is that now we've done looking at group 0, we're going to move on to group 1 and then looking at group 2. So value 1, I see that, okay, it can pair with 5, and then it can also pair with 9, and that's about as best as we can do. So we go 1, 5, and then also 1, comma, 9. And 1 and 5, the way that they are similar is 0, and then they end in least significant bits, 0 and 1, except the one thing that's different about them is this bit right here. And then for 1 and 9, something very similar, except, those are the identical bits between 1 and 9 in binary. Let me double check that. Yeah, that's not right. This is why you double check your work. This is the value and the most significant bit. Okay, moving on. We have 8. I'm gonna check off my 1. We have 8, and we're gonna see what that compares to. So 8 and 9 have a similarity, 8 and 10, as well as 8 and 12. Cool. We have 3 values. So 8 and 9, 8 and 10, 8 and 12 can be little buddies. And things that's similar between 8 and 9 is 1, 0, 0, except for the least significant bit. And that would make sense in your head because 9 is just 1 greater than 8. And then 8 and 10, which is going to be 1, 0, different bit, 0. And then 1 different bit, 0, 0 for 8 and 12. Okay, we are done with 8. We can move on with our lives. Please let me move on. Now we're going to be looking at the final groups, starting with midterm 5. So 5, it can be paired with 7 and 13, it looks like. They're only off by 1 bit for those value pairs. So 5 and 7, 5 and 13. And just to speed things up, I'm going to, actually, I can't speed things up. We should take our time. 5 and 7, the way that they are, or the way you would combine their binary values would be 0, 1 different bits, 1, and then for 11, it would, or sorry, 13, it would be different bits, 1, 0, 1. Cool. We are done with the value 5. Let's look at 6. 6, the only thing it looks like it can combine with is 7, and that would make sense because it is 1 off from 7. So 6 and 7, and their combination of a binary value would be 0, 1, 1 different. Cool. Okay, moving on to 9. It looks like 9 can pair with both 11 and 13. Very cool. We'll write that down here. And for 9 and 11, the way that you would combine those values is 1, 0, different, 1. And then 9 and 13 is 1 different, 0, 1. And then we only have 2 more values left. So 10, let's see, if we're looking at our midterm 10 in the first, or in this group of, I think this is a third group. Yeah. 10 can combine with 13, as well as that is it. That's all you can do with 10. So 10 and 13, the way you would combine those midterms would be, actually, can you combine it with 13? No, you can't. I lied. And so that's why we just erase it and pretend like we never made a mistake. So 10, you can do it with 11. That's what I was thinking. 10 does pair with 11. That would make sense because 11 is 1 up from 10. So that means that the value that's going to be different is that last bit there. And then last but not least, 12 and 13, those values work together because 13 is 1 up from 12. All righty. So we have created all of our pairs in the second column. And now what we're going to do with the second column is pair again, except what you want to do is line up the don't care bits with the other pairs below or from the group below that are, again, we're doing the same thing where we're looking for a kind of binary encoding that is off by 1. So let's do this in not bright green, not today. So pairing 0 and 1, we're looking in group 2 for anything that ends with a, you can consider it kind of a don't care bit, and that's the pairing 8 and 9. And so 0, 1, 8, 9 is a grouping, and that would be, the only difference would be this most significant bit, and then they are sandwiching 2 zeros in between. So then we are done with that value because I don't think anything else in the second group ends in a, or the different bits that don't care is the least significant bit. So let's see if there's a don't care with the most significant bit, and that is 1 and 9. But as you can see, 0, 1, and 1, 9, it's already taken care of by this implicant that we've put here. So we can ignore that pairing. And I think that's the only pairing that you can do. And so we've moved on from group 0. Now, we are going to go into looking at this group. Oh, that was a terrible bracket. This group compared with this group down here. So we're looking at 5, and it looks like this bit in the second to the most significant is what the don't care term is. And we have only one instance of that here. And so that would be 1, 5, 9, and 13 would be the potential pairing. And yes, they are in fact off by this most significant bit here. So that'd be 1, 5, 9, and 13. We can make that a little quad. And that would be don't care, 0, 1. Okay, I don't think we can do anything else there. And then 1 and 9, we're looking for the most significant bit that is different. And immediately I can see that 5 and 13, 1, 5, 9, and 13, except we already wrote that here with our original. So that's not a useful tool. And we can continue going down the list. 8 and 9, the least significant bit is the one that's off. I see in this group here, I'm going to try and keep things clean so you guys don't get too confused. I can see the least significant bit be the don't care bit. There is one here, except these pairings that I've highlighted in red or marked in red, they don't have just one bit off. They're not off by just one bit. They're off by multiple bits. So that's not a correct pairing for when doing a prime implicant chart. So we have to move on with our lives. And I see that these two down here have a don't care in the least significant bit. So they might be of interest to us. And it looks like both of them are of interest to us. So we are going to do 8 and 9 with both these guys. So that would be 8, 9, I believe it was 10 and 11. Forgive my handwriting. And then it's going to be 8, 9, 12, and 13. Cool. All right, we are so close. So 8, 9, and 10 and 11. The bit that is different is the one right next to the least significant bit. So it would be 1, 0, don't care. And then the 1, 4, 8, 9, 12, and 13. It is going to be the value that is closest to the most significant bit. So it would be 1, don't care, 0, don't care. All righty. Now, you could continue this method if you had a lot of variables and you could combine things even more, but we cannot. As you can see, we have reduced our midterms quite a bit, and we've done some pairings and some quads. But the thing you have to do before you identify all your prime implicates, because I think it's obvious to see that this grouping right here, everything in this column is a prime implicate. But you have to evaluate, is there anything we didn't cover in this column? So let's check out the things that we did cover. We covered the first 4 values, 8 and 9. I can see 8 and 9 in my prime implicates in this column, so I'm going to check that off. 8 and 10, they're definitely a pairing. I can see them right here. 8 and 12, they're definitely a pairing. They're in here. 5 and 7 are not in my third column, so I'm going to keep track of that. 5 and 13, they're here, so I can check that off. 6 and 7 are not, again, in my third column, so I'm going to keep track of that. That is also a prime implicant. And then 9 and 11, they are in this value here. 9 and 13, they are seen. And then 11 and 13 and 12, or sorry, 10 and 11 and 12 and 13, these implicants are already taken care of because they are covered in these guys. So now all of our prime implicants can be identified. In this column, as well as these 2 values from column number 2. And let's double check our work. Goodbye. Prime implicants, I have 1, 2, 3, 4, 5 of them. 6. And then I have 1, 2, 3, 4, 5, 6 here. And those are all of my correct prime implicants. So one thing you have to do before, okay, I have these pairings of midterms, how do I get actual Boolean algebra out of them? what you've been doing this entire time. So we zoom in and we see the associated midterm pairings as well as their kind of little encoding in binary. And we can see if we align it with the values A, B, C, D, because we started with a 4-variable function, we can see that B and C are the only values we care about in this particular prime implicate 0. We'll call it P0. And so that would be equivalent to B naught, C naught. And for the next one, it would be C naught D, because this is set high or true. Next one would be A, B naught. The fourth one would be A, C naught. And then we start getting into our couples, not our quads. And so that means that we're going to have 3 variables in our prime implicants. And this is going to be A naught B D, and this is A naught B C. So we've identified all of our prime implicants, and now we can start plugging them into a prime implicant chart. So I am simply going to copy all of these values because it's convenient, and paste them in. So now, in the left-hand column, that is where your prime implicates are going to go. In the top headers, that is where all of your midterms go, not your don't cares, because we do not care about them. So no don't cares here. Sorry, it's ruthless, but we don't care about it. So what we start doing is we go through each of our prime implicants and we start crossing off the values or the midterms that are in those groupings of midterms. So for P0, we see the midterms 0, 1, 8, and 9. For P1, we see the values 1, 5, 9, and 13. Hello, work with me here. For prime implicant 2, we have values 8. Oh, I think my Apple Pencil just died. RIP. But you would continue filling out this chart all the way down to prime implicant 5. And then what we do from there is what is called the Quine-McCluskey theorem, Quine-McCluskey method, where you can use kind of this like crossbar analysis. You can use this crossbar analysis kind of system of eliminating values from your chart and kind of seeing coverage of these prime implicates in order to make sure that all of your midterms are in your final answer. So let's continue on if my Apple Pencil is charged now. 8, 9, 10, 11. So that's going to be 8, 9. Looks like 10 is a don't care term, so we don't care about it. 11, and then finally, or not finally, we have 8, 9, 12, and 13. Again, 12 is a don't care term, and then 5 and 7. 7's a don't care, and then 6 and 7. And looks like 7's not in our header, so it's a don't care for sure. So Quine McClusky, what this person does is they're like, let's start grouping midterms vertically. Just seeing the coverage vertically in all of our values. So you can use either prime implicant 0 or prime implicant 1 in order to cover midterm 1. Same thing for 8 and 9. You can use prime implicant 0, prime implicant 2, or prime implicant 3, because those are all respectively the x's in that column that we've just hashed off. And the way you identify essential prime implicants is who doesn't have a buddy above them or below them. This guy, this guy, this guy. So the way you identify the essential prime implicant is that the only prime implicant that can cover that midterm, at least in 0's case, is this P0 term. So that's essential. I'm highlighting essentials in purple. P2 is also essential in order to cover the midterm 11. And then lastly, P5 is also essential in order to cover the midterm 6. So we have now covered the values choosing essential prime implicates P0, P2, and P5. We've covered 0, 1, 8, and 9. I'm talking about midterms. Prime implicant 2, we've covered 8, 9, 10, and 11. And then P5 covers midterm number 6. So that means that finally, after we choose our essential prime implicates in our minimum sum of products, that is P0, P2, and P5, we need to choose something else to accompany it in order to cover the midterms. Actually, let's work in, yeah, that's a cool color. In order to cover the midterms 5 and 13. And so kind of like how you approach Quine McCluskey is you like go through your rows and you start saying, okay, what can I cross out? How can I cross out both 5 and 13 with the least number of prime implicants? And so I can already see that by doing this, and that you can see I cross out 5, I cross out at 13, and that means that I'm going to include P1 in my final minimal SOP, except I could have also done, in order to cover 5 and 13, P4, which is here, and then also P3, which is here, except I would like to minimize the number of prime implicants in order to make a minimal sum of products. So that would be a reduced answer if I chose, instead of prime implicant 1, prime implicants 3 and 4 to cover midterms 5 and 13, but it wouldn't be the most reduced. And we want it to be the most reduced. So we've identified that this is our function, prime implicant 0 plus prime implicant 2, P5 plus P1, and that is going to eventually, using this translation that we've done up here, we've identified P0, P1, P2, and P5. So that's going to give us a final value in binary to be B naught C naught plus C naught D plus A B naught plus A naught B C. So that is our final answer when it comes to a minimum sum of products for Quine-McCluskey's method. I am going to record Patrick's method in another video, so stay tuned. Otherwise, if you have questions on Quine-McCluskey, it's not going to be on your midterm, but it is really, really important, because this is where I think in the class, at least when I took it, people start losing understanding. There starts to be a division of kids that get it and kids that have no idea what's going on. And I was almost in that group. But luckily, with a lot of studying and like pretty healthy friend group, be prepared for 15A. All right, I will see you in the next video. Other than that, stay safe, guys.